Welcome. Today I will share with you the famous tale of the game of chess between one of the Indian kings and his wise disciple, after which I will explain the mathematical meaning of this video. The story revolves around an Indian king who enjoys playing chess. He once challenged a friend of his, who appeared to be a sage man, promising him that if he could defeat the king, he would ask the king for anything he desired. The sage accepted the king's suggestion, and after a game he won. The king then instructed the sage to make any wish he liked, as he had promised him. The wise man was not an easy person, so he asked for the following reward. Place a grain of rice in the first cell of the chessboard, 2 in the second, 4 in the third, and so on, doubling the number of beats sequentially until the last position on the board. The king agreed, surprised that the man had asked for such a meager reward. He then gave the order to his treasurer to fulfill the sage's request. One pill was placed in the first square, 2 in the second, and 4 in the third one, as the counting began. After a week of counting, the treasurer has returned to the king. Yes, I don't think you were surprised that it took a week of counting. He informed the king that the sage had won a prize that would be larger than India if it were fully planted with rice. The king, who was surprised by the request's first lesser number of the first cell, was stunned. Although there are many different tellings of this tale, we choose this one for our purposes. But why did this number, which was a very small number, suddenly grow to be so large? Let's turn things to mathematical notations. Let us denote by UN the number of rice beads in the nth cell. Then the order of the sage is as follows. UN equals 1 if n is equal 1. And if not, multiply the number of beats in the prior cell by 2 to get the current cell's number, which is represented mathematically by 2un minus 1. We can extract an explicit form of this recursive sequence by performing the following steps. If n is greater than 2, then un equals 2un minus 1, and un minus 1 also equals 2un minus 2, making un equal to 2 squared un minus 2. If we repeat this for another one, we get 2 to the power of 3 un minus 3. As a result, we notice a recurring pattern at each step. At step I, we have un equals 2 to the power of I times un minus I. Keeping going until the very last step, i.e. for I equals n minus 1, we obtain un equals to 2 to the power of n minus 1 un minus n minus 1, which is 2 to the power of n minus 1 u1. And that's how this sequence really looks. Now let us move to see what happens if we compute this sequence for each possible value of n in the chessboard. For the first cell, started with 1 rice bead, the next one 2, then 4, 8, 16, and so on. Remark that after only 32 steps, we have reached billions. Compared to 32, it is a very big number. Let us see what happens next. After only 64 steps, we have reached billion of billion, which are quintillion. It is a very enormous number compared to 64. In fact, this happens because un is a geometric sequence which have an exponential growth. The geometric sequence is as follows. For any raised q and r, un equals to qr to the power of n is called geometric sequence. R is the common ratio and Q is the initial term of the sequence UN. To know the total number of beats needed to fulfill the stage's reward, we could use the sum of any geometric sequence formula. Let Sn denote the sum of a geometric sequence for a natural number I running from 0 to n minus 1. Sn is equal to the sum of ui plus 1 from I running from 0 to n minus 1. Which is the sum of qr to the power of I. Expanding this form and multiplying it by r to get rsn, which is equal to the following. Rearranging the terms as follows and then subtracting the later from the first, we get the following. Sn minus r Sn equals to q minus qr to the power of n. Now the left side and the right side can be factored by Sn and q respectively. Then dividing by 1 minus r, we get the sum. Sn is equal to q factor 1 minus r to the power of n, everything over 1 minus r. In particular for the story, n is equal to 64, q is 1, and r is 2. Then we get the total rice beads needed, which is appeared to be approximately equal to 18 quintillion. Given that the average weight of a single rice beads is 29 milligrams, the total amount of rice required would be more than 5 trillion tons, which could only be produced after thousands of years of rice accumulation. However, what about the time period of this story when humans and production were much less advanced than they are today? I hope that you enjoyed the video. Thanks for watching.